I'm Todd Humphreys, an assistant professor in the Aerospace Engineering Department at the University of Texas at Austin. I'm also the director of the Radio Navigation Lab in the Aerospace Department. December 4th, 2011 was an interesting time.
The other image so many people were studying today, the one coming out of Iran, a video playing on Iranian television, their own soldiers showing off their captured American drone, the one the U.S. lost.
The loss of our spy drone over Iran was a strange and suspicious affair. On the one hand, what the Iranians were claiming was incredible. They said they had taken our drone down with a spoofing attack. They'd spoon-fed fake GPS signals and convinced it to land where they wanted it to land. But on the other hand, the explanation the U.S. Department of Defense was giving was no easier to swallow. They claimed that there was a mechanical failure or a guidance system malfunction and that the drone had come down. But the fact is it came down intact. So there we were with a puzzle. My phone started to ring off the hook because people who had heard that this was a spoofing attack remembered that my students and I had been doing research in GPS spoofing for years now. So they were wondering if it was really possible that the Iranians brought this down as they said they did with a spoofing attack. My students and I got together and said, I'll bet we could do a demonstration showing that the current UAVs that we're planning to bring into the national airspace, unmanned aerial vehicles, are entirely vulnerable to this kind of a spoofing attack. So I got on the phone to the Department of Homeland Security and I said, I know you're planning to do a series of experiments over the summer and you've invited us to this set of experiments. Would you be willing to consider one more experiment? And he said, well, what kind of experiment do you have in mind? I said, this is going to be a spoofing attack and we'll demonstrate that unmanned aerial vehicles could be brought down with a spoofing attack, much like the Iranians were claiming.
Air in 3, 2, 1.
I remember during this preparation time, I couldn't sleep at night because I was imagining all of these disaster scenarios. Maybe the drone was going to get wrapped up in the cord that we were using to send the signals to it in our preliminary test. Maybe we were going to crash it somehow else, and it was an $80,000 device, so it would have been a significant loss for our laboratory. So we knew that we had to go through the motions, test this out before we went down to White Sands to do it in front of the Department of Homeland Security.
I'm holding.
We put the drone through its paces. We made it believe that it was rising vertically upward even though it was just hovering. And in response, its autopilot system tried to compensate by coming straight down toward the pitch.
There it goes.
And our safety pilot caught it just before it hit the ground.
That's probably
5 meters per second.
Yeah.
The truth is, my students and I, up until the very last minute, didn't know if this was going to work. We knew theoretically that, of course, this would work. And we had done some laboratory experiments and so forth, but you can't really do this until you're flying in the stadium. Even after our experiment in the stadium, we weren't sure this was going to work out down at White Sands because there we would have to be broadcasting over the air. This was the real McCoy. And the test was going to be held at night, so we couldn't see things as they were going on. My students and I worked through the night, and at about 3 o'clock that morning, we sent the signal down. The drone was hovering in just the right spot, and we captured it. At 1 here, you see the drone coming down toward the desert floor because we've convinced it that it's actually rising upward. And that was, in our minds, a beautiful moment because it demonstrated that, yes, this is a problem, and it helped to take us on the path to solving the problem. My students and I are interested in a lot more things than we can possibly pursue. But what's interesting isn't always influential, and we'd like to have influence. We really take this University of Texas mantra to heart that says, what starts here changes the world. And so our research is one where we're following our interests, but we're also looking for those things that are going to have the biggest effect on society.